outsider. I am working since long time in the Mediterranean coast and fluvial system, but I'm very far from the Chamal region, usually. So for this first introductory slide, I just present for historiography two images of the Mayence excavation from the 80s and the London waterfront done during decades by the London Museum, which are the pioneering research in fluvial geoarchaeology. So it was important to show it. I have listened with interest a lot this conference and learned a lot. So I have shifted also the organization of my PowerPoint. I almost canceled all the introduction because we spoke a lot about fluvial mobility, and I will focus on the case studies. So as we saw in the previous presentation, what is very important in the fluvial system is what we call the inverted topography, that riverbeds usually are above, in terms of topography, above the fluvial plain. So there is a paradoxical spatial organization that if you want to be not too much flooded, you have to live as close as possible to the channel or the riverbed, which is well demonstrated by this image. The second image is also the settlement model, but we saw the same model during the last days. It's from the Rhone Delta, and we see by the red spot archaeological sites that coincides quite precisely to Paleo-Rhone channel, Rhone of Albaron, Rhone of Saint-Ferréol, Paleo classical period Rhone. And it's interesting to see the organization, not the curvic organization, reflecting the meandering Paleo channel. And there is also in the black dashed line a Paleo shoreline from ancient Tardo-Antique period, and you can see also the location of archaeological sites. So with the absence of comb or turtleback, we have the same organization in the Mediterranean lands for lowlands. I will begin by the first case study. So it's project Aquileia Porto Romano Sponda Orientale. It's directed by Daniela Cottica from Ca' Foscari University and founded by the Minister of Culture and Fondazione Aquileia. And in terms of context, just to replay things carefully, Aquileia is located in the delta of ISONZO, and you must remember that Laguna di Grado was not a lagoon during Roman time, it was a floodplain, and it's only due to recent post-Roman subsidence that the Lagoon of Grado disconnected Aquileia from the Tyrrhenian Sea. There is important fluvial system with the Isonzo Natisone system and some faults which are absolutely fundamental to interpret the mobility of the riverbed, with the defluvration to the east of the Isonzo due to the Monfalcone fault. Aquileia is one of the most famous imperial fluvial harbor. It's a beautiful and well-preserved archaeological park, and you can still enjoy the landscape of the waterfront with the bollards with wood stick in order to attach the vessels. It has been excavated since more than 1 century by Italian and foreigner, and Daniela is still continuing the work with other colleagues, for example, an Austrian team which demonstrate with the French and the Italian and other that in a way, Aquileia is like a Paleo Venice, full of canal, and each canal is at least a harbor, like for Altinum, more close to Venice. what was done with my colleague Arnaud Facetta and a PhD student, Sheisha, it was, and I think it's absolutely fundamental to use this very easy tool called the PASEGA coarse percentile medium grain size pattern. It's a very bivariable grain size analysis, which can be interpreted in terms of sedimentary sources, but mainly on paleo-hydrological dynamics. So for example, on this core taken from Aquileia, core S1, 20-meter depth, it's very clear that since the Iron Age, with a lot of problems of dating, but I will not focus on it, we have, if we see on this document, we see from 1 to 2 increasing fluvial dynamics. So the CM pattern, medium grain signs against coarse percentile in millimeter, is a very useful. And you can see that concerning the active channel, 2000 years ago, you have the core, of course, the coarsest material that have been transported by the river. And step by step, the active channel is moribund and abundant, and you can see a more fine sediment. So it can be usually applied with very cheap and easy in an easy way. For example, with Gilles, we have been able to demonstrate that the channel of the Roman harbor is narrowing with time, which now the team of Daniela Cottica is analyzing more precisely, especially for the eastern waterfront. And the land use had some influences on fluvial dynamics by mainly reduction of some canals and creation of other. This is the excavation in progress where we are involved. And you can see by the yellow color, the main channel, about 40 meters wide. It was in activity during the early imperial period up to the late antique period. And on the east side, the excavation with a round structure, which correspond to a lime kiln of the 5th century AD. And I will give you just not too much detail, but there is something very interesting discovered by the team. It's the vat system from the 3rd century, 4th century for hemp maceration, cannabis, in order to produce cordage. And you have an ethnographic example of this maceration processes, so very close to the channel. With Professor Kaniewski from Toulouse, we have been working on the archaeopalinological content of the core that have been drilled with a mechanic drill called Cobra, which is a easy tool to use. And it's the team in Toulouse were able to make the determination in the lab, a long analytical determination of the pollens, and to classify by PCA, principal component analysis, the different, and classify the different pollens in terms of dryland, dry floodplain, wetland, floodplain, which is very important for Aquileia, but can be easily transferred to Mesopotamia. And this work allow us to produce this preliminary diagram, which is not published, that it's the work of the Toulouse team. And you can see from the 6th century AD on the left of the top diagram, the riverbed drying with sometimes possible flood effect and an enrichment in pollens and freshwater pollens around 1000 BP and 1400 BP. So maybe a signal for more activities. In connection with these riparian forest and marshland evolution and the riverbed drying after 6th century AD, you have also the pollens on the back of the document in connection to agriculture and pasture, who are also an indirect image of a decline of agriculture and pasture between 7th century and 3rd century AD. And after, you have again a development of agricultural practice due to modern times and bonification strategies. So this was the first very recent results from what we are doing presently in Aquileia, and I think archaeopalynology and grain size Pasega diagram should be applied more intensively in Mesopotamia. In the Danube Delta, with Alexandra Bivolaru, my PhD student, who just passed her PhD less than 1 year ago, we were working on different sites on the Danube Delta, which is the second largest delta in Europe, with a very long story of occupation. And it's important to decipher the palaeo-environmental with the evolution of Balkanic culture. It's well known since the work of Diozan and Vespremeanu and other colleagues mainly from Romania and also from Ukraine, that the Danube Delta experienced a successive stage of progradation due to the stabilization of the Black Sea in connection with the Mediterranean Sea, in connection with the world ocean. And you can see since 7,000 years BP, the progressive progradation of the fluvial system from the marine Gulf of the Danube to the lobes, the different lobes of the different branches, fluvial branch of the Danubes. So I will present, if I have the time, two sites very briefly from the fluvial delta, NOVIODUNUM and HALMYRIS, where they are still in publication submitted for NOVIODUNUM, and the first publication accepted for HALMYRIS. So NOVIODUNUM is located on the Roman limes between present-day Romania and Ukraine at the apex of the Danube Delta. It was a strategic site facing the famous Aliobrix, and it was also the harbor, very important for military purpose, because it was the harbor for Classis Flavia Moesia. Thanks to our colleague from Iași University and Professor Assando Lesay and the team, we have been able to work on a leader image, and you can see from on the west side of the what we call the tell of NOVIODUNUM, and the east side, the downstream harbor basin. So we have focused our geoarchaeological research on these two depressions. The so-called tell of NOVIODUNUM is located on a geological outcrop. Here you have a focus on this image with a better scale, and you can see in red the Roman fortification partially dismantled by the concave erosion of the Danube River, and the location of different coring that we have done since a few years, and two excavations that have been done in 2018 and 2019, just before the pandemic. What is interesting, it was for the first time in Romania that an archaeological excavation was done in close connection to geophysics in the context of a fluvial harbor. With Marriner, my colleague from Besançon, we work a lot since 20 years, 25 years about geomorphology of fluvial harbor, and we put into evidence what we call the facies aberration of marine harbor. And you can compare on the left a classic coastal progradational sequence to an artificial anthropogenic harbor sequence on the right. And you can see that the main influence of harbor structure is the fining up of the sediments. So we can say that harbor installations are producing artificial lagoonal environment. It's a little bit the same in fluvial context. In fluvial context, you will find a harbor facies protected by harbor structure. So you will have usually a fining up of sediments, and especially in the case of the Danube, you will have of NOVIODUNUM, you will have a concentration of artifacts and ceramics that have been lost. Because we must have in mind, and it's why harbor basins are so important, that the harbor basins are the dump of the city. All the material is lost, or not all, but most of the material is lost in the harbor basin because it's at base level. It's the same for fluvial or for marine environment, with different proxies, of course. So in the case of the upstream western harbor of NOVIODUNUM, you can see 3 cores with the presence of, in gray, of this Roman harbor facies, very heterogeneous and very rich in a lot of artifacts, human artifacts. The same from the downstream eastern harbor that had been well dated by the ceramics. It was much more problematic with the radiocarbon dating and the import inside the harbor of organic material from upstream. And these are the location with the red arrow of the 2 excavation. I will only show you the one image of the excavation of the downstream harbor basin C0013. It's quite, how can I say, rudimentary walls with difficult impossibility for the moment to interpret the function of this wall. They are located on the bank between the fluvial riverbed of the Danube and the possibly artificial fluvial harbor basin of the downstream harbor of NOVIODUNUM. Work is on progress. It was blocked by the pandemic. In HALMYRIS, it was in connection with the PhD of Mathieu Giem, and you can see the location of HALMYRIS on the northeastern edge of the Dobruja Peninsula. So you must have in mind that 6,000 years ago, before HALMYRIS, long time before HALMYRIS was founded, it was a rocky coast. And on this paleo-rocky coast, paleo small cliff, a jetic settlement was developed since the 6th century BC. And here you can see the triangular Roman fortress in connection with NOVIODUNUM, of course. It's probably mainly for military purpose and inspection function. And so an archaeological settlement with a longue durée between the 6th century BC up to the 7th century AD. The settlement here from an aerial photography of HALMYRIS, which, if I am correct, means in Greek salty water, is in close connection to the present day St. George Arm. But of course, this branch of the Danube change of orientation, even of fluvial style, in the last millennia, and we were able by remote sensing to find paleo meanders of the so-called St. George Arm, which can correspond to a paleo channel just at the edge of the HALMYRIS settlement, and you have two relics, the Mick, Krulik Mick and Krulik Mare, which are ancient floodplain depression that had been after bonified by the communist regime. We have made some corings, and this is one of them, just in front of the HALMYRIS, and you can see on this 7 meter deep core that above a pit that had been eroded, you have a very nice sediment layer full of ostracods, which are very interesting microfauna that can discriminate between marine, brackish and freshwater quite well, and can give a lot of information in connection with geochemistry. And you see that the speed of erosion is reducing, so there is probably also dredging operation that were in process during the Roman period, and we have interpreted this blue facies as a distributary channel of the Paleo St. George, which allow us to determine a water column of about 1.5 meter, which can fit approximately with that was found in Mayence, the Roman ship Mainz 3, which have a draught of 1.3 meters when it's loaded. So it can fit with a flat fluvial boat, even it's not a very important water depth. Let's finish by the last case study, more close to your interest in Giza from an archaeological point of view, chronological point of view, and also climatical point of view. It's in process between Aix-Marseille University, Einschreibs University, National Research Institute of Astronomy and Geophysics in Eluan, and partially funded by East China National University. The idea is coming from Mark Lehner, an American scholar living in Cairo, in Giza, and founder of AREA and member of Chicago University. So as you know, the pyramids were built circa 4,500 years ago, and we have this famous postcard of 1 century ago that show us a beautiful waterscape which totally vanished due to the crazy urban fabric of Great Cairo. So we have this cancer, urban cancer, just at the base of the pyramid. So the problem was to try to find the paleo channel and paleo harbor basins who allow the ancient Egyptians to transport the stones to build the pyramids, because most of the stones which are in the pyramids are, the capping is granitic from Aswan, and most of the stone is limestone from Cairo, so from the west bank of the east bank, sorry, the east bank of the Nile. So you have to transport them for 10 kilometers to the Giza plateau. So you can see in red the limit of the ancient, the limit. These limits have been drawn by Mark Lehner and published by Mark Lehner due to its very important microtopography survey, urban survey. You can see here with the arrow, I hope, ancient Gezira, one and another here. And also he has made a beautiful work collecting data for the sewage system. So he gave us all the preliminary paleogeographical hypotheses to be tested by coring and geophysics. We have made 5 core in a complicated urban context. As you can see, the limit of our work is limited by the Mancheia Canal, which is nowadays a street, because on the west of the blue line, it's under the control of the archaeological antiquity department, and it's quasi impossible to do nothing. But on the eastern part is under the control of the geological department of Egypt, and it's more easy to deal in order to work with geophysics. So what I want to say first that the grain size analysis of the core were quite disappointing, because inside the basin and outside the basin, there is not much difference due to a very homogeneous and high speed of sedimentation. We have a lot of, for most of the core, we have a lot of upside down chronology, which means possible disturbance due to dredging or flood impact. We were very disappointed in palynology. Hadeer Sheisha, my PhD in archaeopalynology with Kaniewski and Morteza Jamali, was very disappointed because she passed 1 year to try to extract pollens with a lot of difficulty, and there is not enough to build a good palynological spectrum. It was very difficult with geophysics. You can imagine in a so dense city, the tomography was inefficient, magnetometry, and so on. All the tools used by the Norriage Geophysical Institute were not totally inoperant, but a lot of pollution, and there is still a lot of work to be done, and also to find empty space. What was the better results was the work that was done under the direction of Alain Véron with PhD Gamal Younes in Serege, Aix-Marseille University. And just last week, we obtained this preliminary image on the contamination. So it's by mass, it's by mass spectrometry, the analysis of enrichment of stable isotope and concentration in ppm of copper and iron. And you can see the horizontal bar correspond to the depth. There is also the main radiocarbon dates that we obtain on this core. There is the concentration in the vertical axis. And there is 2 periods of anthropogenic concentration. These 2 periods, P1 and P2. I will not say much because it would be not very prudent to say too much, but P2 fits quite well with the construction of GIZA necropolis. So possibly the enrichment of copper is due to paleometallurgy and also the use of copper copper tools. P1 is much more complicated to analyze. It's hypothetically connected to the early dynastic period and the Memphis development, but we have to work much more on it. Conclusion on fluvial harbor, natural hazards, neocatastrophic, and mobility. We saw yesterday that the present is the key to understand the past, but we have also to return to the past with the uncertainty of the future, because it's clear that it's clear from my experience in maritime geoarchaeology, in coastal geoarchaeology, that there is a pollution by neocatastrophic research. By chance, Mesopotamia seems not to be too much affected by these neocatastrophic results. For example, in the Mediterranean, tsunami is really a problem because a lot of colleagues are finding tsunami. Of course, tsunami exists, but it's very complicated to make the difference between tsunami and storm. What I want to say, for example, in San Rossore excavation by Bruni and colleagues, they have found upside down boats, and they are very nice, very well excavated and well interpreted in terms of high energy events. And it's for sure For example, if we look on the back of this slide, the diagram of Bersani from Rome, the geologist who produced this nice record of floods since the 5th century BC up to now, that we have a fluvial crisis around during the imperial period. And we have a second fluvial crisis during the Little Ice Age. And it's the same with the diagram of Pichard, which is since the 16th century AD. So I was looking when I was listening to your conference, I was surprised that these hydrological change that has affected the Mediterranean Sea and the fluvial system around the Mediterranean Sea were not detected in Mesopotamia. And I am convinced that Euphrates and Tigris registered the Little Ice Age and the Roman floods. To finish, maybe not the last one, but almost the last, if you are using Google tool and Ngram viewer, you can see from a lexicological point of view, since 2 centuries, the use of two terms that I pick for you, flood and catastrophic flood. And you can see that our problems, our risky society is shaping our research and our wording. So we have to be aware of this. And finally, I love this image of the geologist Fisk from the Mississippi River Commission, who showed this fantastic image of the oxbow and the paleo-meandering Mississippi. And it's the same for Mesopotamia with different fluvial system, more anastomosing and less meandering than in the Mississippi. So all the Mesopotamia between Euphrates and Tigris is a land of avulsion. And the final one, a few years ago, I had the chance to read this book by Susan Scott Parrish, a very good American historian, published in Princeton, The Flood Year, 1927, about the mega flood of the Mississippi, who shaped the geography of the Mississippi, and who is a fantastic book because it's dealing with total geography and total sociology. So I think this book, very far away from Iraq, very far away from the Bronze Age, it can help scholars to understand in what way a fluvial system is engaged in the geographical and archaeological organization of a river, like the Tigris and Euphrates. Thank you.